My name is Thomas Lipham. I'm with the Museum of Discovery, and what we're going to do in here today is learn about stuff. That's right, we're going to learn about stuff. But to start things off, let's go ahead and put all of our electronic devices away. I don't want to be looking at iPhones or iPods or iPads. I want to look at eyeballs, and lots of them. So I want to see all phones and cameras away just for right now. What we're going to do today is learn about the wonderful universe that we live in. So we're going to be learning about matter. Does anybody know what matter is? Anybody know what do you think matter is? Anything that takes up space, very good. Also another characteristic, anything that takes up space and has mass. So this table, does it take up space?
Yes.
Does it have mass?
Yes.
Yes. What about this hammer? Does it take up space?
Yes.
Does it have mass?
Yes.
Yeah, quite a bit. What about the air in between us? Does it take up space?
Yes. Yes.
Yes? No? Maybe so? Controversy in the ranks. It does indeed take up space. Does it have mass? More controversy. Yes, it does indeed have mass. Let me see your thumb. Put it on your arm. That square inch has quite a bit of air pushing on it right now. Our atmosphere, think about all the air that's way up there. There's a lot of air, a lot of gas, and it actually pushes down on you. And so there is indeed mass with that gas or air. So we're going to be learning about different states of matter. Does anybody know some of the main phases of matter that exist? Some of the main phases. What's one? Gas is one. We just talked about that. What about if you were to take energy out of that gas, cool it down, what would you get?
A liquid.
Very good. You'd have a liquid. Now what about if you take even more energy out? Even more, yes? Solids, that is indeed the case. So different energy levels can create different phases of matter. Now, for example, we're going to take a look at a solid. Let's take a look at solid H2O, which is what?
Ice.
Ice. Now we're going to watch it change phase from a solid into a liquid. Ready, go. Shh. We're doing science here, people. Kind of boring, right?
Yeah.
Well, we're going to use a different kind of solid. We're going to use a different solid. So instead of solid H2O, or H2O, we're going to use CO2. Has anybody ever heard of that before? What is that stuff called? Carbon dioxide. That's right. We're going to be using carbon dioxide. But it's not the stuff you breathe out. It's going to be in a different phase. We're going to use solid carbon dioxide, and that is called dry ice. It's pretty neato burrito. What we're going to do is a number of experiments with this stuff. Does anybody know what temperature the environment needs to be to turn liquid water into solid ice? Yes?
32 degrees.
32 degrees of separation between you and Kevin Bacon? No. 32 degrees what?
Fahrenheit.
Fahrenheit, very good. 32 degrees Fahrenheit, or what in Celsius? Big old goose egg, 0 degrees Celsius. This stuff is a lot colder than 32 degrees Fahrenheit. This stuff is negative 109 degrees Fahrenheit. Quite chilly, which is why I have to wear my funny Muppet gloves. My thermal insulating gloves will protect my hand from this dry ice, because if I were to touch it with my skin, guess what would happen?
It would freeze.
It would freeze it solid and give me frostbite, and that's way no good, because I like using my hands for things like thumbs upses, high fiveses, and science experiments. So I will indeed use protective equipment. What we will do is get a volunteer up here to help me experiment with this dry ice. And for that, let's see. I need someone, generally I call on someone that's sitting still, raising their hand, not dislocating their shoulder. So let's go, what's your name?
Carter.
Carter, come on down. Mr. Carter, if you could please put on our highly fashionable scientific goggles right there. We want to protect those eyes. And what we're going to do with Carter is we're going to test this copper pipe. If you could please take a hold of that. Now I'm going to hold it steady, and you're going to lean it up against the side. Let's go ahead and lean it again. Lean against it. All the way against it. Push it all the way against the side. Can y'all hear that noise? Push harder. So, is all solid going to make that noise?
No.
No? Let's test it against another one. Let's test it against this table. I got nothing. What about the floor? Nothing. What about your head? I hear some giggles, but that's it. So let's try it against this. Push it straight against it with the tube facing inward. Let's try that. So we're getting this weird squawky noise. What do we think is happening to make that noise? To investigate further, let's first give our volunteer a big round of applause. Good job, sir. If you could replace the goggles there, I will go into the science behind what is happening with this dry ice. Thank you, sir. You may have a seat. This is very, very cold, and in this room it is warming up right now. Normally, when you have a solid and it warms up, what does it do? Melts into a liquid. Is this melting right now?
No.
What's it doing?
Turning into a
It's turning into a gas. Very good. And that process is called sublimation. What's it called?
sublimation.
That's right. So sublimation, the phase change from a solid directly into a gas. And as it turns into a gas, it causes this to bounce up and down. And you're able to hear that because it's a vibration that you can hear with your ears. That's right. So our next experiment is going to be changing the rate of sublimation, also known as warming it up faster. Do we have anybody that would like to help me with that one? Someone that wants to help me? Let's see. I need to call on just the right person, someone that can follow instructions. And what's your name? Katie, come on up. Katie, if you could please put on our goggles. What we will do is get a couple more chunks of dry ice, and we will crush them up into smaller pieces because we want to increase the surface area. So actually I can get a couple, there's some already pre-crushed ones in here that I will use. What we're going to do is add it to our hot water. Now I've been heating this water up for a while, and it is over 140 degrees Fahrenheit. So it is pretty warm. What we're going to do is combine this with this and see what happens as you quickly sublimate a lot of carbon dioxide. Do we have any guesses? What do you think is going to happen? Ah, we think a lot of gas is going to come up. I like that guess. We're going to get just a little bit more. So, Katie, I have a couple questions for you while I'm getting the dry ice. First off, do you trust me to do a safe science experiment? Yes, good. All right. And do you have health insurance? Like, as in, are you able to go to a doctor?
Yes.
Good, excellent. Now, are you litigious, or do you like to sue people in court a lot? Good, excellent. So we found the perfect candidate. What we're going to do is use some of this dry ice and heat it up very quickly. Are you ready to see that?
Yes.
All right. So I'm going to get this over here. I'm going to combine it. And what we're going to do, well, how about I just show you? Here we go. And Katie, if you could please head in front of the table. What I need you to do is face your audience. Face your audience. Close your eyes and hold your breath. Oh my gosh, what's going to happen? We're going to pour this all over her, get that moisture all in that hair, and there we have it. A round of applause for Katie. So take a look. What does that feel like, Katie? Feels like a gas and it feels warm. That's because we have such hot water. We're quickly sublimating it. In which direction is it going?
Down.
It's going down. Why do we think it's going down? Well,
Heavier than air.
it's heavier than the rest of the air everywhere else. That's exactly right. Katie, you can go ahead and have a seat. Thank you for joining us up here. What we're going to do next is experiment with this dry ice, and for that, I again will need another volunteer. I know you came all the way from Krause, and I'm making you volunteer during a show. What a bummer. Let's get someone from this side. I need someone that can pay close attention, follow multiple steps of instructions, and let's see. Let's go with, what's your name?
Mary.
What's that?
Mary.
Mary, come on over, Mary. What we're going to do, Mary, is put some safety goggles on you, and we are going to put some water in that container. We're going to put some water now. It's going to be tough to see that water because there's so much fog coming out, but I will add it in there. By the way, since this stuff is so warm, or so heavy, we can actually pour it in another container. It'll stay in that container, just like a liquid. Kind of cool, right? So if you could blow the rest of the fog out of there, see how much water we have. There we go. Do we have any water down there? Oh, I think we need some more water than that. I think we need a bit more water. All right, let's take a look in there. How much water do we have now? Perfect. All right, Mary, so this is a multi-step process. What we're going to do is we're going to add a piece of dry ice in there. Let's add, I want to find just the right piece. Let's add this one. There we go. And if you could please place the lid on that. The second half of the experiment is going to be on this side of the table. So you got the lid on? Perfect. All right, if you could please make your way. Oh! Whoa! What was that? You didn't tell me you're a Jedi Master over here. Well, let's go ahead and put, sometimes experiments go a little awry. That's okay. Let's put the lid back on there. And then, is it there? All right, great. So the second half of the experiment is... Mary, we're not going to get done if we keep popping that lid off, so put the Jedi tricks away. And all right, so we need to let that sit there for a minute. Very good. Whoa! Clearly, something is happening. Would anybody like to raise their hand and share what they think is going on in this experiment? What do we think is happening?
Too much gas is going out and making a pop out.
Very well put. So there's too much gas, but where is that gas coming from? It's coming from the dry ice. So when we put the dry ice in the warm water, it sublimates into a gas. Now remember, it's still the same stuff. It's still carbon dioxide, but it takes up more space. And since it increases pressure in here, higher pressure wants to go to lower pressure. And so it pushes the lid until what happens? And we all giggle. Let's give Mary a big round of applause. Thank you. All right, so we've experimented with a solid so far. What I'm going to do is get a liquid. So in a solid, those molecules are packed in tight and they can't move very much. In a liquid, they can take the shape of their container, they can move around a good bit. I've got a really cool liquid here today. In fact, a really cold liquid. What I've got is liquid nitrogen. This stuff is even colder than dry ice. Quite a bit colder. Regular ice, 32 degrees Fahrenheit. Dry ice is going to be negative 109, that's right. So 32, negative 109. This stuff here, negative 321 degrees Fahrenheit. What? That's right. So let's see here. What we're going to do is get some liquid nitrogen in this. And liquid nitrogen is so cold that it will actually boil at room temperature. So let's take a look. Let's see what we've got here. Got some liquid nitrogen. I'm going to go with a little bit more than that. Do you see this vapor coming off of it?
Yeah.
That's it boiling. Negative 321 degrees Fahrenheit. Now I'm going to set this away from me so I don't accidentally knock it over. That would be way no fun. Now what I'm going to do is, this is getting really pretty tiring. I think I need a snack, so I'm going to get some of my Cheetos, kind of my go-to snack. I'm going to just kind of plunk it in there, and I like to kind of get my Cheetos nice and cool. I cook them a little bit, put them in that liquid nitrogen, and get it to get nice and chilly. Now, what I'm going to do with this is eat it. What? What do you think is going to happen?
You're going to die.
No. Let's take a look. It is so cold that it'll cause the air in my lungs, that when it comes out, it will cause it to turn into a fog. So just like when you go outside on a really cold, grouse morning, you get to see your breath. Well, the same kind of thing is happening here. All right, I'm reinvigorated now. I've got my Cheeto snack The next experiment we're going to do with this liquid nitrogen is going to be with one of my favorite things in the world, and that is indeed a balloon. So what I'm going to do is I'm going to put some air inside this balloon, and then we're going to watch what happens when we put it in the liquid nitrogen. I hear speculation in the audience. I like that. I like you guys thinking. So I'm going to set that there. And this balloon's air is roughly room temperature. But what we're going to do is we're going to cool it off quite a bit. Let's take a look. What's happening? So we're going to continue to cool the air inside of it. What's happening to the air as it gets cooler? It is condensing. It is getting smaller and smaller and smaller. And I'm going to use this from now on so I don't freeze my hand. You hear that crinkle? That's the balloon. I'm going to show you this here in just a minute. We're almost there. We are almost there. What's happening now? It's growing. As that air warms up, what is it doing?